On this video, we are going to discuss a very, let's say, I would call it simple mathematical manipulation. So let's go to the question and see what you can do. First of all, mathematical proofs they are very important. They are like mathematical proofs and manipulation mathematics. They are very important. They're key for the reasoning. I mean, you have several reasons why you have to manipulate or to prove an entity. As one simple and very straightforward example, this one is let's suppose have a variable a, a variable b, and a variable c, and you know something about them separately. So you know that somehow you get the knowledge about the two of them in a separate way. So you know that if you make a summation of a, remember that a is a incognita. It's a variable. It can be any variable. Somehow you know that to make the summation of then a plus b, you know that. So see that here you have two things that you can assure, that you know, you are sure about that. So you are sure that a plus b is always smaller than c. This can be, for example, the result of another proof. So you can have a proof inside the proof. So you prove something, then you can use this kind of proof. So that's one of the brilliance, the elegance of mathematics, that you do not have to prove everything. Sometimes what you have in your hand has already been proven by somebody else. So you just have to take that information and go further. So one of the advantages of proofs is that you can do it step by step. If somebody else has proven an entity that's very difficult, you do not have to prove it again. You just can use it for another entity. So suppose that this one was taken for experience or by proof. This one as well. So you know that a plus b is always smaller than 0. You know that a plus c is always smaller than 0. So that's a very simple proof, that you prove that if you make the choice of a plus b plus c is always smaller than 0. So as any proof, you base yourself in a kind of truth that you do not know. I mean, it's a kind of, let's say, it's so basic of human knowledge that you cannot go further. I mean, it's like the cornerstone, the pillar. So in what you have base here, you have base the fact that if you make the summation of two number that's smaller than 0, it has to be smaller than 0. So that's why we were able to shift from this to this, because we take as granted, without any proof, that you cannot prove it. That's let's say the limit of knowledge, the limit of mathematics, that you accept as true, that the summation of two negative numbers is negative. And it's everywhere in your life. For example, if you have a bank account and you have two negative number, your number you never get positive. So it's even a kind of a joke that I have already seen like this. Someone go to a bank and say that there is two negative number in my account, it's still negative. I mean, that's mathematical principle. No one will question that if you have let's say two debit, two things to be paid, it will never be paid by itself. So two negative number is always two negative number. So two minus in your bank account, it will be always a minus. So by this principle that no one will question, you make another assumption that this number has to be smaller than 0. Make my mathematical manipulation, sum this one by this one, and you find this. Maybe here in this context it's meaningless, this manipulation, but maybe in a certain context this simple manipulation can be meaningful, because for now you have just one relation. Before you had two that you had to work with, now you have just one.